Swayam Prabha. Digital India. Educated India.
In this lesson, we will look at the utility of these two port parameters. Let's say we have a complicated circuit, okay, something like this, and it could be even more complicated than this. It could have hundreds of components. Now, I have marked these ports 1 1 prime and 2 2 prime. Let's say you are allowed to make connections only to these. Okay. So, then in that case, okay. So, I will represent this as a box and you are allowed to make connections only to these terminals. Okay. So, in that case, you do not need to analyze the circuit over and over. You can imagine that analyzing such a circuit is quite a job. It is complicated, right? And like I said, it could be a lot bigger than this. This is only limited by what I could draw in a short time. It could have hundreds of components. As long as you are allowed to make connections only to 2 ports, then the whole thing can be reduced to a set of 2 port parameters, and it can be anything. You could choose y parameters, z parameters, h parameters or g parameters. Okay. So, once that is done, any calculation that you need to make with this circuit, you can make with the 2 parameter set. Now, what are the possible calculations that you could be asked to make? I will show you an example. For instance, let us say you had a circuit whose y parameters are given or you have calculated them already. Okay. Now, I could connect a source like this Vs in series with a resistance Rs, and I could have a load resistance to this side, and I define the voltage across the load resistance to be V naught. Now, I need to calculate V naught by Vs. Now, I took this scenario because this is a common one involving amplifiers. On one side you connect a source, the source could be imperfect, so it has a series resistance, and on the other side you connect a load. Okay. So, now again, like I said, we do not need to know what is inside. It could have hundreds of components. You need to do the calculation only once to determine these y parameters, and after that you can simply use the y parameters. So, I am going to show an example. Now, the y parameters relate V1, I1, V2 and I2, and those relations we know. Okay. It is I1 is y11 V1 plus y12 V2, and I2 is y21 V1 plus y22 V2, and now there are constraints imposed by whatever we have connected, okay, on the 2 sides. Firstly, let us take the circuit connected to port 1. We have Vs and Rs connected. So, the voltage drop across Rs is Vs minus V1. Okay. That is pretty obvious considering Kirchhoff's voltage law around this loop, and the current through Rs is this current I1. So, clearly Vs minus V1 divided by Rs is I1. And let me write this in terms of conductances, it is a little more convenient. So, Vs minus V1 times Gs is I1, where Gs is 1 by Rs. And if you look at the output side, this V2 is the voltage across RL and I2 is the current through RL, but in the upwards direction. So, you see that I2 is nothing but minus V2 by RL or minus V2 GL. Okay. And V naught is nothing but V2, because V naught is defined across this and that is the same as V2. Okay. So, now from these we have two equations relating the voltages and currents of the two port. This is a generic relationship for the two port, and whatever we connect on the outside imposes some constraints. We add to that and solve for V naught by V s or V naught in terms of V s. We eliminate all of the intermediate variables V 1, V 2, I 1 and I 2. We have enough equations to do that. Okay. So, let us go about doing that thing. So, I will first substitute this into the first equation. I will have V s minus V 1 times G s to be y 1 1 V 1 plus y 1 2 V 2. Okay. So, this gives you V s G s to be y 1 1 plus G s times V 1 plus y 1 2 V 2, and I will substitute this I 2 equals minus V 2 G L in the second equation, which gives me minus V 2 G L is y 2 1 V 1 plus y 2 2 V 2, and this gives you V 1 to be minus G L plus y 2 2 divided by y 2 1 times V 2. Okay. So, let me copy those over, and from these two I need to eliminate V 1. So, that I have a relationship between V s and V 2, and V 2 is nothing but V naught, the output voltage that I am interested in. Okay. So, putting this into that one, I will get V s G s to be y 1 1 plus G s, y 2 2 plus G L divided by y 2 1 times V 2 plus y 1 2 V 2. Okay. Now, by manipulating this, I can get V naught by V s, which is the same as V 2 by V s, to be minus y 2 1 divided by y 1 1 plus G s, y 2 2 plus G L minus y 1 2 y 2 1. Okay. So, you can take the model of the circuit, model of the two port in terms of the two port parameters, and analyze the whole circuit. Okay. We do not need to look at the insides of the circuit, that is the advantage. Okay. And of course, the two port parameters could be Z, G or H instead of Y. Okay. In this case, I took Y as an example, but it could be described by any other set of parameters. You can do the calculations in that particular set of parameters, or you can convert them into one of the other sets if that happens to be more convenient. Okay. So, this is one of the kind of calculations that you could do